Hello, we are master students representing our cloud computing project related to AWS Cloud. My name is Atifa and I'm alongside with my teammate
Rifana Rashid. In this presentation, we will walk you through our end-to-end AWS deployment, highlight key technical decisions, and share some reflections on our learning experience.
Mm. So our business overview is Grocery Pal 2.0, which is an intelligent cloud powered grocery management system. Its goal is to help users easily track what's in their kitchen, get reminders before the food expires, and automatically create the shopping list. The system supports multiple users, making it ideal for families or shared houses. By deploying on the cloud, um, Drupal 2.0 is always available, scalable for more users, and automatically updated with the latest features and security fixes. This results in less food wastage and more efficient shopping and a more organized kitchen experience for our users. Over to you.
Yes, this diagram shows the complete AWS architecture for Grocery Pulse 2.0. We start with secure AM, IAM role to control access across AWS. The environment is set up in a custom VPC with both public and private subnets spanning two availability zones to maximize availability. The public subnet is connected to the Internet gateway, while private resources securely reach the Internet through a NAT gateway. Our web application is deployed on EC2 instance in both subnets, ensuring service even if one zone goes down. We use Amazon Aurora in the private subnet for robust, high availability database storage with a secondary replica for disaster recovery. AWS Volumes provide scalable storage for our EC2 instance with regular backup for resilience, auto scaling, and an application load balancer maintain performance and app resources dynamically based on user demand. All the key AWS services we use, such as EC2, Aurora, RDS, IAM, VPC, EBS, and load balancer are included in this architecture, providing a clear overview of our full cloud setup.
Um, now we will discuss our AWS implementation and configuration, showing how we configured security, networking, compute, and storage and database services for our business architecture, Grocery Pile 2.0. So here you can see in the screenshot is our IMI role configuration in AWS lab. We used the lab role as our primary identity for managing permissions across the environment. By attaching only the necessary policies, we follow the principles of least privilege, ensuring each resource has the exact access it needs, nothing more and nothing less. This setup makes our cloud infrastructure more secure and also simplifies team management since all actions are controlled and audited through this central role.
This screenshot shows the complete VPC network setup for Grocery Bulk 2.0. We created a dedicated VPC named Grocery Pal VPC with four subnets split across two availability zones for high availability and redundancy. Public subnets are used for resources needing internet access, while private subnets keep sensitive resources like databases secure. You can also see the route tables configured for controlling traffic flow and the network connections set up for our internet gateway and S3 endpoints. This structure ensure both secure segmentation and reliable connectivity for all our AWS resources.
Next you can see that there's a screenshot for our security groups, which is named as a Grocery Pal SG, which controls access to our AWS resources. We define three inbound rules. The first the first allows the HTTP traffic on port 80 from anywhere so the users can access our web application. The second allows SSH access on the port number 22, but only from a specific IP address for securing our application. The third allows MySQL or Aurora traffic on port 3306, again open for connection between our application and the Aurora database. By setting these rules, we ensure the minimum required access for functionality while keeping the system protected from unnecessary exposure.
This slide describes our EC2 instance, which is running the Grocery Pulp 2.0 application. You can see that the instance is in a running state with the name Grocery Pulp Web Server. We choose a T2 micro instance type for cost efficiency during development, and it was provisioned with a public IPv4 address, so our app could be accessed online. The instance is securely deployed within our VPC and attached to the current security group, ensuring both accessibility and protection.
Um, Next is a web feature deployment, which we try to do in the terminal where we started with the Apache web server. Before this, we installed the Apache using the package manager and ensured all necessary dependencies were in place. By managing these steps through the terminal, we demonstrated control over the environment and verified that the server of our web application could serve the Apache database properly. Successfully starting Apache means our EC2 instance is now ready to host and deliver the Grocery Pal 2.0 application to the users.
This browser screenshot confirmed that GroceryPal 2.0 is live and accessible over the internet. After installing and starting the web server on our EC2 instance, we navigate to the public IP in a browser and verify that the application loads correctly. This demonstrates the end-to-end deployment of our solution from infrastructure setup to making the web app available to users online.
As you can see that this screenshot shows the AWS CloudWatch dashboard for our EC2 instance. We actively monitored the CPU utilization and other key matrices, which helps us track server performance in the real time for our application.
We configured a CloudWatch alarm to notify us if CPU utilization exceeds our set threshold. This proactive altering allows us to quickly address any performance bottlenecks and keep our app running smoothly.
Um, to ensure high availability and cost efficiency, we set up an auto scaling group named as Grocery Pal ASG. This group automatically launches or terminates EC2 instances based on the real time demand, ensuring our application scales up during busy periods and also scales down when the traffic is low. This feature helps keep our solution responsive and cost effective.
This slide shows the process of expanding our EC2 instance storage using Amazon EBS. In the first screenshot, you can see that we successfully created new EBS volume with 10 GB of storage. In the second screenshot, the volume has been successfully attached to our running EC2 instance. This allows us to scale storage as needed without downtime, making it easy to handle more application data or perform backups. EBS volumes are highly reliable and can be detached or reattached as required, providing us with flexible and persistent storage.
Here you guys can see that we have created a snapshot for our EBS backup or EBS volume. Taking regular snapshots provides point in time backups, allowing us to restore our data quickly in case of failure or accidental deletion. This snapshotting strategy is essential for protecting our application data and ensuring reliable business continuity.
After backing up our storage, we also created an Amazon Mission Image or AMI of our running EC2 instance. The AMI captures the full state of the server, including the operating system, application code, and configuration, making it easy to launch identical instances for scaling or quick recovery. This approach gives us complete backups coverage and supports both disaster recovery and efficient scaling.
This screenshot shows the successful creation of Amazon Aura database cluster. Aurora provides high availability and automated backups, making it an ideal choice for storing Grocery Pals application data. Also, this database is hosted within a private subnet, so it's isolated from public internet access for added potential security.
Here we demonstrate a successful connection from our EC2 instance to the Aurora database. This confirms that our application can securely interact with the database using private network with no public exposure. The connectivity setup was tested to ensure seamless data flow between the web server and the database backend.
Um, here first we created a target group in AWS. The target group defines which EC2 instances will receive traffic from our created load balancer earlier. It's essential because it allows us to control health checks and automatically registered or deregister instances as they scaled in or out. This ensures that only healthy and running instances serve user request.
Next, we created an application load balancer. This component distributes incoming traffic across all healthy instances in our target group, improving both availability and reliability. The load balancer automatically detects the health of the instances and ensures user is always connected to an active server.
Mm, Um, as you can see, this is the final screenshot which shows the DNS link of our load balancer. This is the public endpoint users. This is the public endpoint which users can use to access the Grocery Pal 2.0 application. The DNS name always points out to the load balancer, which routes requests to the currently healthy backend instances, making the system resilient to failures and easy to scale. So here are the challenges we faced during this implementation, um, which was especially with configuring Amazon Aurora and connecting it securely with our EC2 instance. How we basically overcome it. Um, after reviewing the AWS course modules, Lab 5 specific to be specific, and which guided us through the correct process of creating and connecting the database. Following the step-by-step instructions helped us complete this critical part of the project.
One major challenge for me was configuring security groups correctly, especially balancing accessibility for testing with maintaining strong security. And how we overcome it was like we carefully read AWS documentation and experimented in the AWS console, adjusting inbound and outbound rules. I also consulted class notes and discussed with peers, which helped me achieve the right security setup for the application.
So basically, my personal reflection about this whole assignment has been a valuable learning experience. Setting up a full AWS cloud architecture from networking to security to compute and databases gave me a practical analysis and practical skills beyond the theory which we did in our lectures and as well as in our lecture slides. I now feel a bit more confident in my ability to deploy real world cloud solutions and troubleshoot technical challenges, some of the technical challenges to be precise. So, collaborating in a team with Rifana also taught me how to divide tasks and communicate effectively.
For me, my personal reflection includes working on this assignment improved my understanding of cloud infrastructure and security. I learned how crucial it is to plan architecture carefully and to document every step for reproducibility. Solving hands on issues in AWS has boosted my confidence and prepared me for future projects, whether in coursework or industry. The teamwork aspects also showed me the value of sharing knowledge and supporting each other.
Thank you so much for watching our presentation on our business proposal and our AWS deployment journey.
We appreciate your time and Hope you found our project and learning process insightful. Thank
Thank
you.
you.